Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Magic. Today today's focus incident is we're going to talk about a power disruption that affected one of the data centers in our West US region. On the 7th of February, we'll talk about the trigger event that led this, that started this event. We talk about the failing over to generators, and finally we'll speak about the long-tail recovery for a subset of compute services.
That's right. So to talk us through the impact and our learnings, I'd like to introduce the engineering leaders joining as our guests today. Joining us live in the studio here, we have Francis David. Francis is our Partner Group Software Engineering Manager, who's going to talk to some of the Azure Compute recovery. But first, I'd like to introduce Navin Sethi. Navin is our General Manager from the Data Center Operations team. And so both of these folks are going to talk us through what happened and what we learned today.
Super. Navin, perhaps we can start with you. We run hundreds, I don't know how many data centers we have. We have like 70 odd regions around the world. Surely power losses are a dime a dozen. What's supposed to happen during a power event where we lose power on a good day?
Yeah, thanks for the question, and thanks, David and Sami, for having me here today. Yeah, just a quick answer to your question. We have hundreds of data centers around the world. So what's meant to happen when a data center loses power is when a utility power is effectively lost, we have backup systems that are designed to come in and provide continuity, right? Our UPSs, which is uninterruptible power supplies, those systems detect the outage and provide battery-backed power to critical loads while backup generators automatically stop, right? So that's the kind of like from the first part. The second part is the ATSs, which are known as automatic transfer switches. Those transfer the electrical load from utility to generator power once the generator stabilizes, ensuring racks remain energized throughout without any interruption. That's the sequence of what's meant to happen. And if you'd like, Sami, I could talk a little bit more about the setup in West US in this particular site, but would you like me to go through that?
Absolutely, please. The more salt and pepper we can offer, the better.
Great. So in this particular location in San Jose, it actually incorporates what we call a 5 to make 4 distributed redundant design. It's a distributive redundancy. That's the way we describe it. It creates a level of fault tolerance in the electrical distribution design itself, right? That's where the total critical load is actually spread across multiple independent lineups. For example, think about 5 lineups where each are loaded to effectively 80% of their rated capacity. And in the event of a single lineup failure, the entire 80% of the load is redistributed effectively equally across the remaining 4 lineups. And those each absorb an additional 20%, bringing them from 80 to 100 of rated capacity. And that ensures continuous operation without interruption.
That's great to understand what's supposed to happen. I like the way Sami said, on a good day. So Francis, maybe let's continue the story there. From the compute perspective, what is supposed to happen once power is restored to a data center?
Once power comes back, the compute servers are configured to all power back on independently. And in a good day, these should all just start booting back up, and just like your laptop, start functioning again. And this VMs that are hosted on that from that power the compute instances are all supposed to also automatically start up. And everything typically comes back up very rapidly on a good day.
Got it. And I know we mentioned it, don't want to steal your thunder for later in the story, but on a good day, we've got a repair system that's supposed to be doing some recovery elements. Would you just help us to understand that before we get to the outage we're talking about?
Of course. So even on a typically good day, there tends to be a few servers that are like stragglers. They have some challenges in getting back to a healthy state, and in the process of them getting shut down potentially gets them marked as unhealthy. And there's a repair system that we have in place. This system kicks in and detects these corner case issues and attempts to fix them. And on a typically good day, these repair systems kick in very fast as well. And these last few VMs or servers that are not responsive do get fixed. VMs get moved around if necessary, if there's a hardware failure, for example. and the system automatically is designed to recover from all of these pretty rapidly.
All right, super. So even on a good day with that thing's working, and it's designed also to work when a bad day happens as well, and that system kicks in.
As long as it's not a very bad day.
Super. But let's fast forward to let's fast forward to a bad day now, Navin. On the 7th of February, we had a power loss event. Now, utility power was still working. You mentioned, hey, when there's a utility interruption, but the utility power was still working the whole time. So we were getting electricity in, but the electrical failure was with an on-site transformer, and that's what caused the issue here. Could you elaborate a little bit on that?
Yeah, let me walk through, Sammy, the incident itself and kind of break it down, right? So as you mentioned, February the 7th when the incident occurred, what we actually had was a failure of a voltage transformer and its associated cabling, actually, right? On a site-owned substation transformer. And that failure caused a rapid voltage rise that propagated downstream into the UPS, which I mentioned earlier is an uninterruptible power supply input path. And because that upstream protective relay was not effectively configured with overvoltage set points, the overvoltage condition itself was not contained, it wasn't arrested, and it reached the UPS modules, right? So in response, the UPS systems effectively entered into a protective shutdown, which they're designed to do. That prevents the equipment itself from not getting damaged. And as a result, the UPS-backed power was lost not only to the critical load, but also to the facility overall, the facility control systems. So while the generators started and were capable of carrying that load, the loss of UPS-backed control systems prevented that automatic transfer to generator power. And that led to rack power de-energization effectively across all the key co-locations within that facility, right? So the sequence of the events that occurred, right? So we had, we'll break it down into 4 things. We had equipment failure. That was the incorrect rated cable that failed. That created effectively a voltage surge of approximately around 130% of normal levels. The second part was the unprotected electrical surge itself. And because the protected relays were lacking over voltage settings, the surge traveled unchecked effectively through the electrical system. So then the third part was the UPS shutdown itself. The power system detected this abnormal voltage, and they shut themselves down to protect themselves, to prevent equipment damage, and it functions exactly as designed. And the fourth and the final part of the failure in the data center infrastructure side was this ATS control failure. Because the control system lost power when the house UPS systems, entered this protective state that I described, and they went into shutdown mode due to that over voltage condition, which left the ATS without any control power needed to operate. So that's really how it broke down.
That's really great to understand, because I think, we've had a couple of power-related issues before where generators didn't start up properly. And I think it's important, I just want to reiterate, you're saying the generators started up properly, everything was fine there. It was the control system that's then meant to route the load to them, and that's what's failed. That's really interesting to understand. So, Navin, now that we understand all those different pieces of all those contributing factors, would you talk to us about kind of on the day, how did we detect it, how did we investigate it, and how did we go and restore power? I assume the detection was pretty quick. If a building stops and all of the servers in a building stop, people notice pretty quickly?
Yeah, absolutely, David. So there's a couple of things, right? So the outage was actually detected. We talked about February 7th. It was actually detected quite late on in the late hours of Friday night, Friday the 6th, right? Super Bowl weekend, via our August telemetry system, which is Microsoft's proprietary monitoring platform that we use for time series infrastructure telemetry to automatically detect, correlate, and alert on our critical environment and our availability systems, such as rack outages, power, cooling, and those type of faults. And it's really it serves as our first signal. So within minutes, Argus alerted, and the telemetry identified multiple racks down. Exactly to your point, David. We knew within minutes, right? So we declared the outage. Obviously, we have all the timelines in the public PIR, and then we mobilized our data center operational teams. The recovery continued effectively into the early hours of Saturday morning on February 7th. And the power restoration itself really broke down into 3 stages, right? Stage 1, in terms of the recovery, the technicians opening the utility breakers, they closed the generator breaker, and then all the boards transferred to generator power. There was one exception, and we had to resolve that further downstream. And then stage 2 is the operational completion of the troubleshooting, the remaining UPS faults, right? The tripped breakers, manually restoring some of the generator power to the remaining racks. And then the third and final stage is the full electrical redundancy on the utility power itself. That was restored after transformer repairs, over voltage protection repairs that we need to do and corrections, and control the re-energization itself. And so, that timeline effectively from a power recovery sequence perspective, David, was, let's just say, so it's 91 minutes within the initial fault itself, right? The ops team restored control power to the site. And around six out of 10, I would say, critical load lineups automatically switched to the generator power. We restored the power to about 90% of the racks. Then just over 3.5 hours later, of the initial fault, the site team was able to complete the troubleshooting and the recovery and manually restore the generator power to 100% of the racks.
Wow. Okay. So at this point in time now, we're running on generators. It's 3.5 hours later, and Evan, you're kind of done. And so I'd love to turn my attention to Francis. Francis, right. You spoke a little bit about the recovery system in place, and today was a bad day. How did the recovery system do? I gather there were some delays in the recovery system working. What were the issues that the recovery system faced itself?
Good question. So there was a lot of interesting stuff happening in this particular outage. One of the things that was happening was we do have hosted within the same data center some of our internal workload, Bing in particular. So we do run on the same infrastructure as external customers, and Bing was sharing inventory in that data center. And what happened with Bing is that they ended up also going down when the outage happened. But they are running unique configurations. They are running pre-release features, internal experimental features that are not yet ready for prime time. And they had a lot of behavioral differences when it came to recovery when this power was restored in this particular data center. And they ended up generating a lot of load to the repair system. And typically the repair system is able to kind of handle the long tail of recovery in a data center outage scenario. In this particular case, there was a bit of a challenge with the additional load coming from these Bing VMs, which are large clusters as well, with a large number of VMs. And it did result in a little bit of an overload going there.
Was there something unique about Bing? Is it their configuration? Is it their workload type patterns?
It was indeed a combination of their configuration and their adoption of experimental early features that they were using in that particular environment. And so the combination of both of them resulted in their VMs not really starting up at all, and they were all firing off repair requests into the recovery system. Okay. And given the scale of Bing in that particular region, and it did generate a volume of repair requests that came into the recovery system that overwhelmed it to an extent.
And that ultimately is what delayed the compute coming back online for your usual virtual machines and things that run on there.
Yeah, while a large number of VMs did come back up quickly, this long tail, the last few things that have a little bit of a challenge getting through to like a perfect functional state, those were affected by the fact that the repair system couldn't really react. It was really overwhelmed by all of the other load coming in.
Got it. That makes sense to understand. So that explains some of the long tail recovery when it comes to the compute coming back online. I think a lot of customers, as we were talking about, expect, well, you've got power. What else is happening? But like you're saying, there was a lot happening in the recovery systems to try to get those into a good place. So this is probably a good opportunity for us to pivot over to our learnings and repair items. Maybe we'll go in chronological order again. So Nevin, I'll come to you. There were a couple of different repairs and learnings from the data center perspective here. The number one of which, after all this conversation about generators, the big one is around reconfiguring that control system. Is that so that the transition to generators could have happened more seamlessly and we wouldn't be here talking about impact?
Yeah, I think there's a couple of things, David. There's probably two very critical learnings and repairs, and of course there's many more than this, and these are the two fundamental ones. The first one is around the control system reconfiguration for the generators effectively. So following the event itself, the overvoltage protection settings in the upstream relays were reconfigured to ensure we don't have future faults, and they're isolated before impacting downstream control systems. So to go back to your point, that is fundamental. Those reconfiguration steps really preserve the control power integrity, right? And that enables the generators and the automatic transfer switches, called ATSs, for short, to function as designed, right, during during any future power anomalies, right? So we've corrected that. That's number one. The second one, David, is the reprioritization of the critical infrastructure and the power restoration sequence itself, right? So the loss of the UPS-backed control power during the event itself prevented that automatic critical load transfer, making it clear that restoring that control power was really the top priority for the broader infrastructure recovery itself, right? So the data center infrastructure team, the operations team, I should say, focused first on reestablishing the control power before energizing the critical load lineup. So we've gone through that sequential learning, we've gone through that power restoration sequence learning, and as you mentioned, the control system reconfiguration. And then, of course, there are other things that we've learned from this particular event, including, the level of the resourcing that we have at site, the response times. We always want to learn from how we can be quicker and more driven towards the resolution path and the timeline. So yeah, I would summarize it as that, David.
And Navin, can I double click on an area we spoke about? When something goes down like this, we have is there a prioritization? In the PIR, we spoke about reprioritizing critical infrastructure. Is that what you've touched on, or is there something more where we sit down and say, okay, we need to prioritize this piece? Is it internal? Is it external? Is it the sequence of event? Could you help me understand that a little bit more?
Yes, I mean, what I would say is a couple of things. So, sequentially for us internally within the data center, obviously, you're not going to do anything without power, without our networking. There is a defined sequence of recovery when you're in that type of situation where you're effectively dark, right? That's not going to change. I think the other piece of your question, though, Sammy, is really about the recovery internally. And that's probably more for us to talk about internally in terms of, you're on a bridge call, there's a lot going on, right? Obviously, there's a huge amount of focus in terms of bringing our customers back up. And I should say we apologize for the impact to all of our customers on this call. But, that sequential recovery is dependent on the infrastructure sequence of recovery that we have at site. That is very much defined, Sammy, right? The other piece about the other services that we bring up, we're also very clear in how we do that. We just had to be very careful in terms of protecting the load as it came back online. We were dealing with quite a lot of unknowns in the moment, right? Obviously, we've done a huge amount of analytics since, February the 7th. We're almost a month down the line. We've learned so much. Obviously, we put a lot of repairs in place, and we've provided a lot of learning to our people on the ground as well. But I think the fact that when you're in the moment, you're very focused on, first of all, the safe recovery of services, the safe recovery of the data center infrastructure, I should say, and then the safe recovery of the services. And so I think there's more to come on that internally as well, Sam.
Super.
That's cool. Thank you for stepping us through that. I mean, similarly, if we turn to Francis and compute, what can we do to improve that recovery system you were talking about? How do we make sure that is more stable or more robust to be able to help in situations like this?
Yeah, so the quick takeaway for us from this whole incident was the fact that we did not necessarily have all of the right safeguards in terms of being able to handle the surge of load that came into the recovery system in this case. And so one of the things that we immediately took an action to do is to go build in that resilience into the system. So figure out how do we prioritize the requests coming in, how to kind of throttle duplicate requests coming in, and so on. So we took some, filed some work items, and developers are working through fixing those as we speak. So this would at least help with a lot of that surge management and speed up recovery in the longer term.
So the other PIR item, which I find fascinating, we said that we are refining how services come back online to make these more robust for different failure modes. This is the only repair item that I think I can remember in the last 5, 6, 7, 8 years that doesn't have an estimated time to complete. And so could you speak to us a little bit about that?
Yeah, the thing that we are doing in order to kind of build resilience to kind of issues of this kind is that we do very high frequency drills of this nature, right, in many of our data centers. And this is something that as a cultural thing really helps because it helps identify issues before they affect external customers. And we have a lot of variation, a lot of different features and capabilities. And we are shipping so much new technology all the time, new AI, VM SKUs, and more. And the amount of variation we have demands that we constantly exercise and evaluate our resiliency to issues of this nature. And so this constant activity that we do helps provide feedback to us on an ongoing basis where we take those learnings, incorporate them into our playbooks for faster recovery. So we get learnings such as how do we prioritize the recovery process itself, which services would we bring up before the other services, any orchestration requirements necessary to optimize and essentially bring up everything as fast as we can possibly. And so that really is an ongoing exercise that never ends.
Right, that's why we don't have an ETA date. We're always making improvements in that regard. And it's great to understand things like, even full power restoration in a building. These are scenarios that we drill and see how things come back online. I mean, you've touched on some of the learnings from Microsoft's perspective. Francis, what should customers learn from this? We always like these sessions to include more on customer resilience or how customers could have weathered the storm better. I know the West US region doesn't currently support availability zones. So what can customers do to be more resilient to failures?
Of course. So wherever you do see a region that does not really have availability zone support, it's something that customers with mission critical workload would have to really internalize and make sure that they have plans, because we do have multi-region capabilities, right? And the ability to leverage those does build in additional resilience for customers that have that critical workload. In our case, for example, Bing was able to fail out of that region, and they weren't that stressed out about the fact that their VMs did not come back up. Customers that have critical workload should adopt similar practices. That said, we are always trying to get most of our regions to have multiple availability zones. It's an ongoing exercise that does take time in some cases, but for customers that do see that those regions that we have with just one availability zone, I would recommend that they focus on building resiliency.
Got it. That's great to understand. Nevin, is there anything you wanted to add to that? I assume you're not about to preview a timeline or make any announcements here?
No, David, I'm not going to make any announcements here. Thanks for that question. But I would say, look, we have over a dozen data centers in the US West region. So we have a number of data centers in that region. I want to stress that. We are, of course, growing within that particular region as well. That will come over time. I would just go back, David, to a couple of things, and I think this session has been so helpful for us to really talk more transparently about data center operations and our infrastructure. We apply a growth mindset to this. We talk about this a lot in Microsoft. The learnings from these type of events are shared across our ecosystem, across all our data center colleagues, regardless of where this happened in US West, across the not only across the US, but also globally as well. And we obviously look for any thematic learning, right? Anything that we can resolve where there could be similar setups in other facilities. We've gone through that process, and just to reassure our customers on the call, we've already gone through that process and corrected one other location where this existed. We've obviously looked very closely at the resilience of this particular location as well. And we'll continue to do that. You made a great comment, David. That we don't have an ETA on excellence. We're consistently striving to drive towards operational excellence and the highest level of uptime. And we'll continue to do that. So I just want to reassure all our customers on the call that that's part of what our team does in data center operations as part of CI+I and Microsoft.
Oh, that's great to understand. What a cool feedback loop. Outages should teach us something new about our cloud and how it works. So great to hear that that's being fed back into improvements. I've saved my last question for my co-host, Sammy. Sammy runs the incident communications team. How did we do on comms?
So whenever there's an outage, human beings are slow to correlate impact and so on. So in this case, the fortunate thing is our Brain file. Brain is our AI ops telemetry thing. So impacted subscriptions would have received early notification to say, hey, there was an issue with some of their services, not for everything. Now, the Brain is wonderful when it comes to single service, single region, but when there's multiple services or it's kind of a broader impact, Brain doesn't do so well. So we had about 12 of these fire off all at once, but wrangling them because they all had West US in common, was pretty easy. We decided to go broadly and communicate on our public status page, in addition to communicating behind the auth wall in the portal, so that customers understand that the impact was broad. We tried to list the impacted services because, as Navin mentioned, we have over a dozen data centers. Not everything was impacted. If it was only the one data center, sure, it would have been absolutely down, but we had over a dozen data centers up and running as well, and it was one. So we listed the impacted services that were there. The moment we got an ETA with power restoration, we started communicating it. And so once we had power restoration, we didn't anticipate the recovery system running into issues as well. But as we kind of learned more about that, we started offering those ETAs. So while outages do happen and they're painful for customers, we know one of the things we want to do is say, we think it's going to take 2 hours, 3 hours, 4 hours. At times we've been wrong, and that's okay. But we want to give customers some sort of a yardstick so that they can understand this is how we're doing. The other piece I'll mention is that the PIR for this came out late. Typically, we try and publish our PIR within 14 days. We can't say what happened until we know what happened. And as Navin, particularly Navin, has spoken about, there's so much extra information that keeps coming in. I think some of the things that Navin spoke about, we didn't get to include in the PIR. And so every day that we were running late, we thought, okay, we're about to publish this, and we would learn more. And we want to try and include as much as we can for customers. It's not about hitting the date, it's about sharing what we can. Particularly, as Navin said, not only so our customers know what happened, but our industry can learn from us as well. In addition to our Microsoft ecosystem, our industry can learn about some of these type of failure types and how they can be immune to this.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure Well-Architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.